Thank you, learners. Welcome to this channel again, where I'm going to facilitate on optimizing chemistry practical performance. I'm teacher Stephen Cage, a journey through the mind of examiners. So we have to know what the examiners are thinking and what they are testing and what they expect from us. So work with me as we proceed on. So the content of this presentation is uh, to dig deep on examinable areas, anomalies and graphs between practical and theory, current dynamics and emerging trends in setting and marking of chemistry paper 3, and also the common errors by the student. So the pillars of the chemistry, we have a reactivity series, first 20 elements, solubility of salts, the mole and the organic chemistry. So if you can be able to understand these pillars, then trust me, because almost 20% always come from these first 20 elements. The reactivity series, you have to know which element is reacting more than the other. They will help you in tackling many questions. The solubility of salts, very important, to help even in qualitative analysis and quantitative analysis. The moles concept is everywhere, can be tested in paper 1, paper 2, and paper 3. Organic chemistry, very common. So if you can at least take even 3 pillars here, then you work on them thoroughly for the time remaining, trust me, you'll make a positive impact. Then we have the practical exam in chemistry, clearly aims at testing whether the learners has acquired the following. So ensure whether you have attained or acquired the following as you prepare for your KCSE that commence on 2nd of next month. Whether you appropriate manipulative skills, whether you have acquired the manipulative skills, you can manipulate questions and at least interpret what is needed until you bring your knowledge to writing. Skills in making accurate observation, accurate recording of results, ability to analyze and interpret scientific data, ability to follow the sequence of instructions and carry out the experiments, ability to recall and describe a sequence of instruction and carrying out experiment. So I'm sure you have that. So the following are the major areas which can be tested in chemistry practical. Eating curve, this one has been tested. You can refer to 2005 and 2021 last year, where they were told to determine the freezing point. The qualitative analysis, test for cations and anions. This one is a must. Qualitative analysis on organic chemistry, this one is a must, except for 2021, it was not there. To win this year, it must be. 2021 rate of reaction, this one, not 2021, another major area is the rate of reaction. This one you can refer to 1992, 1999, 2000, 2012, 2016, and 2019. So you can see It has taken time before it is tested, just the way I see it in curve. Also, we have the thermochemistry. So the thermochemistry, that is where we get the exothermic, endothermic, heat of reaction, such like things. So that is where we have the thermochemistry. It is commonly tested. You can see 1990, 1989, 1994, 1995, 1997, 2000, 2001, 2002, 2004, 2005, 2007, 2008, 2010, 2013, 2014, 2017, 2018, and 20. No, this one is not there. It was to be 2019. So this one is 2019, not 2020 or 2. Maybe it can also be there. The solubility, it has really taken time. That is 2006, 2017, and 2015. But sometimes it is tested in paper 2, like that and like that. So titration, this one is a must, except for this year, for this, that is to 1995, 2000 to 205, 202, 2016. So those years, they were not there. The rest of the years, they have been tested. So to me, I feel for this solubility, reaction rate, and this thermochemistry. And organic was not there, it must now be there. Qualitative analysis under the test for cations and anions, that is a must. So work on that. Titration, work on it thoroughly. This one, don't want to discuss it now. So titration, we begin with the titration. Types of titration, always we have 3 types of titration. Direct titration. Direct titration is just acid-base titration. So that is where we react a base, neutralization reaction, I mean. So this one is always where we react strong acid and strong base. So wherever you see these 2 products, the strong acid and the strong base, know that that is a direct titration. Then in direct titration, a substance is not directly titrated, but precipitated or removed from the reaction, and the product form has to be titrated. So where you will be able to you can be told to filter. After filtering, so the filtrate or the residue is what you are using in titration. So back titration, a titration analysis which involves the reaction of a given amount of a sample with a given volume of known concentration or the molarity, which is in excess, and then the excess is titrated against the standard solution. So this one you can refer to 2011. So we have some formulas for calculating moles. Moles can be gotten by molarity times moles can be gotten by molarity times the volumes. That is, in most of the cases, it can be moles. There is one that is said moles is equals to mass over molar mass, or the RAM, or the RMM. So that is one. Another one is moles is equals to molarity, that is moles can also be gotten by polarity, polarity times volume used times volume used over 1,000 over 1,000, just like that. Then now the molarity can be moles times 1,000 over volume used. And we have also another way of calculating molarity. Molarity can also be calculated as mass in grams per liter over RFM. So you can know that. So in mass, also the mass in grams per liter can also be calculated as molarity times RFM. RFM can be calculated as molarity and then mass in grams per liter over molarity. So any of the formula you can derive by making a subject the formula. So you can check on this. Mole ratios when you react acid and the monoacid, and this one sodium hydroxide plus hydrochloric acid, the mole ratio is 1:1. Sodium hydroxide plus HCl, sulfuric acid is 2:1. Sodium hydroxide plus phosphoric acid, that is 3:1. Sodium hydroxide plus dibasic acid, that one there, that is 2:1. Sodium hydroxide plus triacid, that is 3:1. Calcium hydroxide plus hydrochloric acid, 1:2, and it goes on like that. M carbonate plus that is HCl is 1:2. Sodium carbonate plus hydrochloric acid 1:2. Sodium carbonate plus sulfuric acid, that is 1:1. Any sodium salt hydrated one will plus acid. This is, we call it octahydrated. The one with the 10 moles of water, the hydrated water plus sulfuric acid, you will get 1:1. We have this, that is hydrated sodium oxide, which is also a salt, will plus water will give you that sodium hydroxide plus this acid, which is called acetic acid, which is also known as the oxalic acid. The oxalic acid, that is 2:1. Not acetic, but oxalic, sorry. It is oxalic acid. We have also filling the titration table. It is always 5 marks, and this is how it is awarded. Completing the table. So long as you complete the table using the realistic values. The realistic values are the values which ranges from 0 to 50. So any value which is above 50, because you know that the bill rate reads from 0 to 50. So any value which is below 0 and above 50, that is a realistic, that is not realistic value and will miss that 1 mark. So you must fill the table with the realistic values. Use of decimals. The use of decimals should be consistent throughout the table. So if you have decided to use one decimal place, ensure that in all the table, you use one decimal place. That is, if it is 24.0, let it be 0.1 decimal, maybe 2.25, 24.5, 24.6, and what have you. Then accuracy. So accuracy comes with the square value. Then we have the principle of averaging. The principle of averaging, where you only take the values which ranges from or negative or positive 0.1 or 2, or positive or negative 0.2, that range. So for example, if you have 25.3, another one is 25.9, another one is 25.2. So you will only take this one and this one, you add them, then you divide by 2. So you ignore this because this one is not in the range of negative or positive 0.2. Then let me come here into decimal. If you have chosen to use 2 decimal places, the last digit should be either 0 or 5. For example, you can't have this 24.34. This is wrong. So the last digit should be either 0 or 5. So ensure that is taken home. Then the final accuracy, now after averaging also, we'll check with the school value. For you to get this 1 mark full, your average or final accuracy, your final value should be between positive or negative 0.1 of the school value. You'll get to 1 mark full. But if it ranges from positive or negative 0.2, then you will be given a half, the same as to this part C. So note, in calculation involving moles, should be given at least in 4 decimal places. So when you are calculating moles, ensure that your decimal places are not less than 4. Calculating formularity should be 3 decimal places. Units are not necessary, but if given, they must be correct. Wrong units penalized a half. So if it is if you were to give the unit, like maybe mole, like this, then if you are not sure, better you leave it without a unit. But if you're giving out the unit, ensure that it is correct. Like if you write like this, then even if your answer was correct, then you will be denied a half a mark. So you be keen. If you don't know, better you leave it the way it is. RFM and RMM have no units, and this is a common mistake with most students, stating in grams. Maybe if you're told to get the the relative atomic mass of sodium, then you come and write maybe sodium 23, then you write grams. This is very wrong. RFM, RMM, and M should have no unit. Unit mass in grams per liter is the small letters, all of them, small g, small l, not small g, capital L. This is wrong, so you have to check on that. So practical summary notes, analysis on qualitative analysis. Qualitative analysis. So the qualitative analysis, this practical will require a candidate to be able to identify, test for cations and anions in organic qualitative analysis. In qualitative analysis, you look for what you hear, the sound produced, e.g. cracking sound, what you see, the color of the product, precipitate, color of filtrate, color of residue, color of the gas produced, color of the sublimate, the color of the liquid formed when a vapor condenses, effervescence, effect on red and blue litmus paper, or universal indicator, glass rod dipped in 2 moles of hydrochloric acid, effect on burning and glowing wooden splint, anhydrous cobalt-2 chloride, and color of the solution. So here, whatever you see, so here you use your eyes in giving the color of anything that you see. So whenever whenever maybe you use, for example, if you use sodium hydrogen carbonate, there you will be talking about the effervescence and the color of the gas produced. Again, when you are heating, you will be able to give the color of the sublimate. When you are heating a solution, the color of the liquid formed when a vapor. For example, also if you've been given a solid substance, then you are told to heat it. Then at the cooler part of the test tube, you will see maybe the color of liquid form. So you will only see a colorless liquid form at the cooler part of the test tube. Again, effect on red and blue litmus paper. You can also be given a solid substance. Then you will be provided with this litmus paper. Whenever you are provided with this litmus paper, ensure you use them when you are heating a substance. You dip it in water because you know that the gas has no effect on dry litmus paper. So you ensure that you you dip them in water, then you mount them on the inside wall of the test tube that you are using. Then you will be able to observe the color change. The glass rod dipped in on the concentrated sulfuric acid, also you will be able to see the corrosion. You will be able to see the liquid on the glass rod. Effect on burning and glowing splint. Maybe if you are testing a gas, you are provided with a wooden splint, you will use it, the glowing one. If it rekindles, the gas which is produced. When it goes off with a pop sound, the gas which is produced. When you are using cobalt-2 chloride, maybe you are testing the liquid. That is, you check the color of the cobalt-2 anhydrous and also the hydrated one. When you are talking about the smell, you use now your nose. We have the choking, irritating smell, and also we have the pleasant smell, compounds, maybe when the alcohol, that is alkanoic acid, and alkanols, you react them, then you heat the mixture, then in addition of the concentrated sulfuric acid, you will be able to get the smell, the pleasant smell. Then you describe the test for the cations, describing the test to test the cations. These are now emerging trends. Nowadays, they always sometimes give you the reagents and what have you. So you are told to give the procedures, you give the test, you give the conclusions, which are now the inferences. So you should be able to know that. Preliminary test. These are the initial tests in chemistry practical questions. The initial tests on the chemistry practical are summarized below. Heating. This one is always done in a boiling tube. Here you look for the gas produced, its color, smell, and effect on blue and red litmus paper. You also look for the sound produced. Does the sound melt? No, does the substance melt? If it is solid, does it melt? You know, in heating it, we only heat the solid substances, but in boiling, we boil the liquid substances. So here, does the liquid that you are heating melts? The color of the residue. You look for water of crystallization or even a sublimate. Note, when told to heat gently, you are only looking for the water of crystallization. When you are told to heat gently, you are only looking for water of crystallization. For example, which can be tested using a blue dry cobalt 2 chloride paper, which turns to pink. When told to heat strongly, you are looking for the gases evolve. Test them using a litmus paper or a wooden splint. Color of the residue and the color of the sublimate. So what are the residue and what are the sublimate? So the residue is what remains and the sublimate is what gets out. So check on this. Possible results. Observation. If you do an experiment and you see a colorless vapor that condenses on the cooler part of the test tube to form a colorless liquid, or the blue dry cobalt 2 chloride paper turns pink, you will infer or you will conclude that that is a hydrated salt, or you can say water of crystallization present. But you can say hydrated, so the one you see. So when you heat it gently, when you heat and get that a gas that turns a moist red litmus paper blue and no effect on blue litmus paper. If you are using if you are using the litmus paper, ensure that you use them both red and blue, and you state the effect on each. If there is effect on blue litmus paper, you say there is no effect on red litmus paper. So to me, that is acidic gas. The acidic gas that is acidic gas turns moist red litmus paper blue. Acidic gas, so that is the ammonium present. So that is what you write. A gas that turns a moist red litmus paper blue and a blue litmus paper red. So here, a gas that turns a moist red litmus paper blue. This is not acidic, but basic gas, because it has no effect on blue litmus paper. So a gas that turns a moist red litmus paper blue and a blue litmus paper red, white sublimate form on the cooler part of the test tube. See some white sublimate, some white solid or powder-like. Those are the sublimates. So know that that is still ammonium, which is a basic gas. Ammonium salt present, ammonium ion. So that is reasoning. Sodium chloride, that is ammonium chloride, sorry, decomposes on heating to get ammonia and hydrogen chloride gas. So realize that there will be a white ring which will be formed. So that is that, being that the ammonia diffuses faster than hydrogen chloride gas, because this one is less denser than that. So ammonia is lighter and diffuses faster, hence the litmus paper turns from red to blue. Then later, this acid now turns the blue litmus paper red. That is later one. You should be able to know that. Then also this one, the solid melts. Brown gas is evolved. Cracking sound and yellow residue remain. So this one, it means that it can be either nitrate ion or lead ion, because you know that the lead oxide, for example, is yellow when hot. So that is the solid melts, and that the gas is evolved, and that is maybe these two are now present. A colorless gas evolved which relies a glowing splane and no effect on both red litmus paper, both the litmus papers. So now know that is fluorite ion, nitrate ion, manganese ion, and oxygen ion, the neutral substances. Colorless gas evolve which relights, because they will produce oxygen gas which relights a glowing splane, tied to no effect of litmus paper, tied to a gas that relights a glowing splane, so they have no effect on the litmus papers, because there is no any hydroxyl ion or the hydrogen ion which can have effect on those litmus paper. Colorless and odorless gas that extinguishes a burning splane is produced. That is the carbonate ion, where we'll be able to get the carbon dioxide gas. A colorless gas evolve, then that will turn a filter paper soaked in a potassium chromate from orange to green. So that is the sulfate ion, which will now produce the sulfite and also the sulfur oxide gas. So that is that. It will continue with this later. So you can subscribe to the YouTube channel, so that at least when I upload a new video, you can be able to see and get notification.